All right, guys, I'm going to go over page A from the AP Prep Geometry summer homework. We've got some basic arithmetic skills with fractions. So we're talking about adding, subtracting, multiplying, and dividing fractions. So one of the important things to keep in mind with this whole process is when you're adding and subtracting, you need to make sure you have a common denominator. In this case, right here with number 1, 9 and 8, not a common denominator. We need to change that. When you're multiplying or dividing, however, it doesn't matter. You can have common denominators or not. You can still do the process without changing them first. So I'm going to go ahead and go over a couple examples here. So I'm going to do number 1. We've got 7 over 9 plus 3 over 8. And we need to change these denominators to be the same. So a quick way to find a common denominator is just to simply multiply these two numbers together. So 9 times 8 would be 72. Now I know that is a common denominator, but it might not be the lowest. So you want to run through your options, see if there's a lower one than that. But in this case, there's not. So 72 is going to be our LCD, our lowest common denominator. And we need to change both of these fractions to make that happen. So I'm going to multiply this first fraction, multiply it by 8. I need to make sure to multiply the top and the bottom by the same number. And that's going to give us 56 over 72 plus. And then this one we're going to need to multiply by 9 to make that a 72. When you multiply by the same value on the top and the bottom, you're not actually changing the value of the fraction because you're multiplying by 9 over 9, which is really the same thing as 1. All right, so we get 27 over 72. All right, now that we have common denominators, we can simply add these two things together. We're just going to add the numerators. So that's going to give us 56 plus 20 is 76. Plus 7 more, that's going to be 83 over 72. All right. After you add, you want to just make sure that you can't simplify that all if there's no common factors between these two numbers. In this case, there is not. This is as simplified as that answer is going to get. All right. Let's go ahead and do a slightly longer one here, one with just kind of a mixture. All right, number 6. 6 over 5 plus 12 over 5 minus 3 over 2. So for these first two here, we already have a common denominator, so we can go ahead and add those two together. We get 17, by 17 I mean 18 over 5. And we're still subtracting 3 over 2. Now we need to make a common denominator. So again, you can find a common denominator of 10 by just multiplying these two together. You want to make sure that's the lowest because otherwise you're going to make some big numbers, but 10 is the lowest we can go here. So for this fraction, we need to multiply the top and the bottom by 2. And this one we need to multiply by 5. So that's going to give us 36 over 5 minus 5 over 10. A couple mistakes there, sorry. And 15 over 10. Now that we have a common denominator, again, we just simply subtract these things and we're going to get 21 over 10. Doesn't simplify. There's no common factor there. All right, so that was an example with some addition and subtraction of fractions. Let's go ahead and try some multiplication and division problems. So I'm going to start with number 3, just to talk about multiplication. So when you multiply two fractions, you're simply multiplying the top times the top, the bottom times the bottom. So before you do that, however, you want to see if either fraction simplifies. In this case, they do not. Or if diagonally these numbers have common factors that can be divided out. So 6 and 5, this numerator and this denominator, they don't have any common factors. and 5 and 12. Again, no common factors. So there's no simplifying that I can do before, so just go ahead and jump right in. 6 times 12 is going to be 72. 5 times 5, 25. That's it. You want to see if you can simplify that, but I know you cannot. All right, and one more. We're going to talk about division. So whenever you're dividing fractions, the fraction you are dividing by, the divisor, you're going to be taking that and changing it into its reciprocal and changing this into a multiplication problem. So it looks like this: 6 over 5 times 5 over 12. So we took this fraction, turned it into its reciprocal. That's because division can always be thought of as multiplication by the reciprocal of that number. So instead of dividing by 2, you could simply multiply by 1/2, for example. 1/2 being the reciprocal of 2. All right, this one's a good example because there is going to be some simplifying at this stage. These fractions don't simplify, but when we look diagonally, we have common factors. These are both divisible by 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. So that simplifies a little bit. And then diagonally here, we also have some simplifying to do. Those are both divisible by 5. So we get 1 and 1. So really what we're doing is we're multiplying now 1 over 1 times 1 over 2, which of course is going to be equal to 1 over 2. Now, I'm going to go ahead and show without the simplifying just to make sure that that does work, even if we don't simplify first. So if we step back a little bit to this stage right here. So before I simplify, I can go ahead and multiply and I'm going to get the same answer, but it'll take one extra step at the end. So 6 times 5 is 30. 5 times 12 is 60. And isn't it true that 30 over 60 is the same thing as a half? Yeah, those are both the same. So that's just our simplified fraction answer. All right, now let's go ahead and look at some of these problems involving mixed numbers. Let's do number 10 here. So we have some mixed numbers. So before we multiply them or add them or subtract them, we're going to have to change those mixed numbers into improper fractions. Pretty easy process. You take your whole number, multiply it by the denominator, and then add that to the top. So it's getting 5 times 2, which is 10. 10 plus 1 is 11. So 5 and 1/2 turns into 11 over 2. Same process over here. 2 times 3 is 6. 6 plus 1 is 7. So this becomes 7 over 3. Now this kind of turns into a very similar process to what we did up here. We're subtracting these two fractions. We first have to have a common denominator. So common denominator here is going to be 6. So I'll multiply this one by 2 and this fraction by 3. And we'll see what we get. We get 33 over 6, 14 over 6. And when we subtract those, 33 minus 14, 19 over 6. Now, this is what we call an improper fraction. A lot of our answers so far have been improper fractions. Generally, that's fine. I like to leave my answers in as improper fractions unless I'm told otherwise. Simplified improper fractions, but this is a fine method. We could change that back into a mixed number if we want, but I'm gonna go ahead and leave it like that. All right, let's do final problem, 16. So 16, we have some variables in here, so we're not gonna be able to simplify into a single kind of a normal fraction. There's still going to be a variable as part of our answer because it's not an equation. We're not solving for it. We're just trying to combine stuff together as much as we can. Since this is subtraction, we're going to need a common denominator. So that's going to go ahead and be the first thing we do. Common denominator for 2 and 3, we just found that it's going to be 6. So multiply this one by 2 on the top and this one by 3. When we're multiplying the top by 3, we need to make sure we distribute to everything. Same thing over here. When we multiply the top by 2, we're going to need to make sure we distribute. So that's going to be first place where it gets a little tricky. So go ahead and distribute this one. It's going to be 15x plus 21 over 6 minus 2 times these. So that's going to be 6x minus 8 over 6. Okay. So now we have a common denominator. Now we can kind of go ahead and put our numerators together. Here's the second place where things get a little tricky. Since I am subtracting this fraction, I'm subtracting this whole quantity up here on top. I'm subtracting a 6x and I'm subtracting this 8 that's also already being subtracted. So I need to be a little careful. I'm going to go ahead and rewrite this all grouped together like that. So it's going to be 15x plus 21 minus 6x minus 8 all over 6. Now you could skip this step. I just want to show kind of where it's all coming from though. Now, again, I'm subtracting the whole quantity that's in the numerator here. So I'm sort of needing to distribute this minus here, distributing that as a negative. So we get 15x plus 21 minus 6x, so distributing that there, plus 8, since we're subtracting something that's already negative. And then the final step here will be to combine like terms. 15x minus 6x, 9x, 21 plus 8 is 29 over 6. So that one took a little more work, a little more kind of algebraic manipulation there with the variable. But that should be our final answer.